Hello students, now this is second lecture of your function. We have already studied that what is function, how to define this, and what are the criteria, what are the restrictions on that. Based on this, we know that we have to find domain as well as range of the function. So now, what is this domain, how to find this, how to apply in the concept, direct question in IIT-JEE will come from this domain or board examination will come from this domain and range. So we have to score good. For that score and understanding the concept, we have to be very carefully see this lecture, and conceptually you will be very strong and you can get 100% marks in your examination. So let's start and enjoy your domain and range. Last class, we have seen domain of the function. Domain of logarithmic function. Log fx base gx. So the first condition is fx greater than 0. Second, gx greater than 0. And third, the base gx not equals to 1. So we have to apply these three conditions, and these three conditions must satisfy simultaneously. What is the meaning of this simultaneously? See with the example. Let the function is y is equals to log of x minus 2 base x. So according to the rule, first is x minus 2 greater than 0, second is x greater than 0, and third is x not equal to 1. So make the number line. Condition first, x greater than 2. Mark this 2. This is going to 2 to infinity, right? Second is x greater than 0. There is some 0. So in this case, x greater than 0. The second case satisfying for x greater than 0. Third is x not equal to 1. Except 1, all the values, right? So 1 is there, 2 is there, 0 is there. Now we have to find those areas where all three patterns are satisfying. Means this portion, shaded one, the cross one, and the line one. So we can see there, this is nothing but the answer 2 to infinity. The all three is satisfying this for 2 to infinity. So the domain of this is 2 open to infinity. Infinity is always in the open bracket, right? One more example of this, you can go like y is equals to log x minus 1 base x minus 4. See, condition first, x minus 1 greater than 0. Condition second, x minus 4 greater than 0. Condition third, x minus 4 not equal to 1. Make the line x greater than 1. Mark 1 there. Greater than 1, the shaded portion, write off this 1. Second, x greater than 4. Mark 4. The values greater than 4. And from the third one, x is not equal to 5. Except this number 5, all the values are satisfying, right? So again, we have to see which portion is satisfying all three, 1, 2, and 3. So see, the number 4 to 5 union 5 to infinity. or we can write this as 4 to infinity negation the number 5, right? X belongs to this number, or domain is given in this form, right? So again, we have to see the graph of the function. After graph, we can see lot many different domains of the function, and we have to also see the algebra of the function, right? So a little bit question we are doing for range, and in this range, the questions like, if I'm giving you y is equals to x square plus x plus 1, find range of this. Like y is equal to quadratic, maybe linear upon quadratic, maybe quadratic upon quadratic, maybe quadratic upon linear. All those cases when we have to solve for range, right? You have to take help of quadratic, like x square plus x plus 1 minus y is equal to 0. Now see, coefficient of x square is 1, coefficient of x, that's b, is 1, and coefficient of c is 1 minus y. You have to write down this ABC. If possibly you are getting in terms of y, it's okay with that, right? Now, we know that discriminant D means b square minus 4ac is always greater than equals to 0, right? b 1 minus 4ac greater than equals to 0, 1 minus 4 plus 4y greater than equal to 0, or y greater than equal to 3 by 4. This is giving you 3 by 4. This sign is equal to also. So 3 by 4 to infinity. 3 by 4 is closed. Infinity is open. This y belongs to this. So range in this case will be 3 by 4 to infinity, right? So if the questions are given in different forms, like few examples I'm giving you, y is equals to, it's a symbolic, I'm writing fx plus 1 upon the same fx minus 1. And fx could be anything. This fx may be sin x, may be sin square x, e to the power x, right? Maybe x square, maybe tan square x, any value is there, right? And then we have to find range, right? Then how to find range in this case? See, what you have to do. Step first, always go with cross multiply, or simply I can say we have to find value of fx in terms of y. So this is y minus 1 into fx is equal to 1 plus y, or fx is equal to 1 plus y upon y minus 1, right? So we have to find this function of y in terms of fx. So fx is equal to, we can write 1 plus y upon y minus 1. Now, let's suppose I'm saying this fx is nothing but let e to the power x, right? The question is given in this form. And we know that any power is always greater than 0, right? So we can rewrite this as 1 plus y. So you have to give the restriction on this. Means if it is sin x, so sin x lies between minus 1 to 1. Sin square x lies between 0 to 1. E to the power x always greater than 0. x square greater than equal to 0, tan square x greater than equals to 0. So if the case is like e to the power x, this must be greater than 0. Make number line, right? This is -1, this is 1. Put any value greater than 1, positive, negative, positive. We require the positive side of this, so right side and left side. This is minus infinity to -1, open bracket because there is no equality sign, union 1 to infinity, right? So when we have to find range, right, many different questions would be there, right? So step 1, you have to find fx, right? Step 2, you have to give the restriction. Step 3, you have to make the diagram. And this is step 4, you have to carefully write down the answer of this, right? So this is about the range of the function, okay? Now, little bit we have to see the graph of the function, then only we'll be able to, right, find the domain and range or the different variety of questions, right? So starting with the basic graph of the function, how to draw the graph or how to like get the domain and range with the help of that. Let us suppose I'm saying that first in the graph, this is very important chapter, right? The graph itself give you a very good like understanding of question. Like if I'm saying the first graph we are doing is with constant function, right? What is this constant function? F R to R means domain is R, codomain is R, and function is given y is equal to fx is equal to some constant, let I'm saying 4. Any constant would be there, 0, 1, -1, -10, √2, √3, √5, anything, right? So y is equal to fx or the fx is equal to 4 is given, right? So if we want to see this in Venn diagram, we can see there, this is set A, this is set B, and different values are there, 1, 2, 3, 4, 5. We are giving the values of x, but every time, right, not many values are there, right? 6, 7, and so on. Every time you are getting the same value, same image are coming, and that is 4 only, right? So every time we are getting some value and that is 4, right? So this is known as constant function. If you want to draw the graph, this is y-axis, this is x-axis, y is equal to 4 is a line parallel to the x-axis and going like this, right? This is the point 0, 4. This is the origin, right? This is x-axis and this is y-axis. We can see there, right, different values of x. We are getting same values of y, right? Same values of y. So this is called constant function. In this case, you can see domain of the function is all the real number. You can take any values of x, right? And range in this case is a singleton value, and that is 4 only, right? This is 4 only. So domain and range through the graph. This is the first example, right? So going for the second function, the graph of second function is identity function. Identity function. What is this identity function? Let's suppose again we are taking this fr to r, right? Y is equals to fx is the function, and that is equal to x only for x belongs to r real number. Means domain in this case is all the real number R, and we can see with the graph only, this is y-axis, this is x-axis, and we have to draw the graph of y is equal to x. This is the straight line coming like this, right? Y is equal to x. So this line y is equal to x is going to infinity when x is going to infinity. So range in this case is minus infinity to plus infinity, or again we can write R, or we can write this also minus infinity to plus infinity, right? This is for identity function, right? So lot many functions are there that we can draw, or we can just use these functions in different way. So if in the case we are taking an example for any polynomial function, polynomial function means maybe this could be quadratic, cubic, or fourth power, and many more powers are there, right? So different techniques are there to draw the graph of the function. If we are using this for any function that can factorize into 2-3 parts, right? Just I'm giving you the simple example of y is equal to x minus 1, x minus 2, and x minus 3. How to draw the graph, right? First, draw the axis. That will help you to know this, right? This is origin, this is x-axis, this is y-axis, right? 3 points are there, 1, 2, and 3 when this becomes 0, right? Now, if I'm putting any value greater than 3, this will be positive. Any value between 2 to 3 negative, then positive, then negative, and going negative to minus infinity, right? With the help of this, we have to draw the graph. Now, greater than 3 going to infinity, again negative, positive, and this going to minus infinity. We can also check this value. This we are getting at x is equal to 0, you are getting this is minus 6, right? And for infinity, this is going to infinity. For cubic function, also we can say this is the graph, and we can draw the graph accordingly, right? So in graph of the function, right, when we have to draw the different graphs, right, as like we have seen, y is equals to x minus 1, x minus 2, x minus 3, x minus 4. In the factor form, all the 4 graphs are given, and now we have to draw the graph of this, right? So how we can go with the graph? Y-axis, x-axis, points are 1, 2, 3, 4, again positive, negative, and then it will be positive, right? So 4 at 4, this will be 0, and 4 to infinity, this will be positive, going to negative. Then at 3, this will be 0, right? Positive, negative, up to this, and again going to infinity, right? This having 4th degree, so at infinity and minus infinity, in both the cases, you are getting this is tending towards infinity, right? But when we have to find the range, we need these values, right? In the cubic equation, we can say for the cubic equation, it was R, but in this case, we have to find these peak values, and for those values, we have to use dy by dx, right? So obviously, next class, we'll see that how to go for dy by dx, right? So if I'm drawing the graph, next one, y is equals to 1 upon x plus 4, right? This is one of the beautiful graph, or we can start with, for your understanding that will be good, if you know the graph of y is equals to 1 by x. This is known as rectangular hyperbola. In this rectangular hyperbola, what you have to think, this is the y-axis, x-axis, at x is equal to 0, this will be not defined, and this is going to infinity, and at infinity this is going to be 0, right? And at exactly 0 this is not defined, right? For negative values of x, this y will be negative, both are negative, right? And same for very small values of x, this is going to infinity with the negative sign, this will minus infinity, and with infinity this is going to 0, right? So this is the nature of the graph. For y is equal to 1 by x, right? This portion going down and this portion going down, this is known as rectangular hyperbola. Now, but we have to draw the graph of y is equal to 1 by x plus 4, right? This is known as shifting. Later on, we will go for that, how to shift the graph. But in this case, we can see there, right? At x is equal to minus 4, this is not defined. See, this is not defined at x is equal to minus 4. So this could be the line, right? Line parallel to the y-axis. So this going to infinity, and this is the portion, and this going to infinity, and this is the portion, right? So this is the graph of y is equal to 1 by x plus 4. Right. So if we have to find rectangular hyperbola, this is one of the beautiful graph, and for shifting of graph or the rational graph, this is very important, and we'll use this method to write it down, right? So more of the graph, and the most important function for your competitive exam is modulus function. Modulus function, like f r to r, function is defined fx as mod x. First, you have to understand what is the meaning of this mod. See, the function fx will be x when x greater than equal to 0, and this has to be represented as minus x when x less than 0. Look into this. If x is positive, so you are getting x only, that is positive only. And if x is negative, you are writing this minus x. Minus x means you have to put negative before minus sign. So this is again coming as a positive one. Mod function is a function that's give you the magnitude. Always, this will be always positive, right? So if we have to draw the graph of this, again, look carefully. So at 0, this will be 0. For x greater than 0, this will be y is equal to x only, and this is the line, right? Again, for minus x, right? For negative of minus x, again, y will be positive, and you are getting the same values there. I'm saying you are putting x is equal to minus 1, right? You are getting minus of x is equal to plus 1. So y is equal to minus x, you'll give you 1. That's the same value you are getting at 1. So at 1 comma 0 or minus 1 comma 0, you're getting the same pick, or pick that value of y will be 1 in both the case, right? And we can see this is the y-axis. So any modulus function is symmetrical about the y-axis, right? Or symmetrical about this y-axis will say you that this function is fx is same as f of minus x, Or we can say f of 0 plus x is same as f of 0 minus x. If in the question it is given symmetrical about y-axis, so you are writing 0 and 0. If I am asking the graph, any graph, not modulus, any graph is symmetrical about 2. So f2 plus x must be equal to f of 2 minus x, right? In this case, this graph is symmetrical about x is equal to 2, right? The line x is equal to 2, then we have to write it. But the question is not there. Our question is y is equal to mod x, the function, or fx is equal to mod x. So what is the domain? Domain of the function in this case, domain is R. We can take any values of x. You can see it's going from minus infinity to plus infinity. And range of the function from 0, it's going to infinity. So range of the function is 0 to infinity. 0 closed, right? Or we can write R plus union 0. Or we can write R minus of R minus. R means all the real numbers and R minus, so that all the negative part you are subtracting from this, so you are getting all the positive numbers, right? So this is the case of modulus, and very, very, very important, right? Next class, we'll continue with this graph, and lot many different graphs are coming in next class. Thank you.